In this video, we will be learning about ratios, proportions, and exploring unit rates. For problem 1, we are asked to write the ratio in 3 different ways for this scenario. If you can type a 550-word paper in 12 minutes, write the ratio of words to minutes. The first thing we want to do is identify what our ratio is representing. In this problem, our ratio represents words and minutes. So we need to find the numbers that correspond with words and minutes, and then we will write our ratio. In this problem, we know there are 550 words for every 12 minutes. So our ratio will be 550 words for 12 minutes. Now, just like in all math, if we can reduce, we should. And this will reduce, so we can reduce this down to 275 over 6. And that is one way to write the ratio. We have to write it the other ways as well. We're going to use that reduced fraction to do it though. So we're going to write 275 to 6. That's another way to write the ratio. And the third way is with a colon. So 275 colon 6, which we would still read 275 to 6. In example 2, we are asked to solve the proportion rounding to the nearest tenth. The first thing we're going to do to solve this proportion is cross multiply, because if two ratios are equal, their cross products are equal. So we're going to take the 70 and cross it over with 14 and multiply those two numbers. 70 times 14 is 980. And then we're going to take 21, cross it over, and multiply it with x, which would make just 21x. Now we need to get x by itself to solve this equation, so we're going to divide by our 21 to get x by itself. So that's going to leave me with x on one side, and on the other side I've got 980 divided by 21. When you take 980 and divide it by 21, you're going to get a long decimal list on your calculator that's going to look something like this. And then it's got a bunch of 6s on your screen, and it's going to end with a 7 because your calculator is automatically rounding. This question says round to the nearest tenth, so we need to decide, this is the tenth spot, we need to decide if that 6 stays a 6 or goes up to a 7. The way we decide that is by looking at the number right after the tenth spot. And in this case, it's a 6. If this number is 5 or more, it tells me to take this tenth spot and move it up 1 to a 7. So my final answer for this is going to be 46.7. When you're done, you should take a minute and make sure this makes sense. If you put 46.7 in this spot for x, would this fraction be equivalent to this fraction? Well, you can see that 14 is less than 21, and my 46.7 is less than 70. That's a good indicator. You could also do 14 divided by 21 on your calculator and see if you get the same decimal as when you do 46.7 divided by 70. Because remember, if this is a proportion, this fraction should be equivalent to this fraction, meaning they have the same value, whether they're in fraction or decimal form. For example 3, we are asked to decide which is the better buy. If we could buy a bag of Doritos that contains 14.5 ounces for $5.94, is that a better buy than buying the small bag at 2.5 ounces for $1.29? What they've done here is actually tricked us into doing two problems in one. In order to answer this question, we need to decide what the unit rate is for each scenario. So in order to find a unit rate, we need to know what two units we're talking about. And in this problem, we have ounces and we have money. So when we go to set this up, we know we're going to have ounces and money. For the first scenario, we've got 14.5 ounces, and that costs us in money $5.94. Now we've got two more spots to fill in, and we're not going to use the other bag of Doritos. This is just for that first bag of Doritos, so I need another number. Well, when we're looking for a unit rate, the other number is going to be a 1, and we have to decide which spot it's going to go into. We want to know how much this cost per ounce. So we want to know how much money it is for 1 ounce of Doritos. So my ounce is going to be 1. And the question here is how much money. So that's why X goes in the dollar spot. At this point, we're going to be able to cross multiply to figure this out. So I take X times 14.5. That's just 14.5X. And 5.94 times 1 is 5.94. Next, we need to solve for X. So I got to move the 14.5 over by dividing both sides of the equation by 14.5. And it says to round to the nearest hundredth, which means 2 places. So after my decimal point, I need 2 decimal places. If rounded correctly, this one is going to be 0.41, which means we're paying 41 cents for 1 ounce of Doritos. Now let's look at the second case. In the second case, we have 2.5 ounces, and it's costing us $1.29. And we again want to know how much money, there's my X, for 1 ounce. In order to solve, we're going to again cross multiply. So X times 2.5 and 1.29 times 1. So 2.5 times X is 2.5X, and 1.29 times 1 is just 1.29. To get X by itself, I need to divide by 2.5. That's going to get rid of that and leave me with just the X, which is what I want. And again, we're rounding 2 decimal places. So 1.29 divided by 2.5 is 0.52. So the unit rate for the first one was 41 cents per ounce. And the second case, the smaller bag, was 52 cents per ounce. So as long as you plan on eating all the Doritos, this is a much better buy because it's so much cheaper for each ounce of Doritos.